Morning, class. Hope you're doing well. By now we've already covered all of chapter 2. That means that we're finally done with all the asymptotes and all the graphs, for now at least. And we're going to begin talking about exponential and logarithmic functions. Now, this will be your material for the final test, so please pay attention. Now, what I want you guys to do for now, it's quite simple. You're going to go to the book, page number 391, and I just want you to write down the characteristics of exponential functions of the form f of x is equal to b of x. All right? So when we think about exponents, we normally have x squared, x cubed, and so on and so forth. But now the new part is that our exponent is now a variable, see, x, right? And this brings a whole new set of characteristics, all right? So if you can, please copy them beforehand, and I will proceed to explain them right now, all right? You can pause the video, go to your book, whatever you want. So number one, it says the domain of f of x is b of the domain of f of x is equal to b to the power of x consists of all real numbers. If we remember that domain is all the values of x. Okay? So what it's telling us is that any number can be placed in the exponent, any real number at least. Okay? From negative infinity to positive infinity. But the range, in other words, any output, the value of y, of this function consists only of all positive real numbers from 0 all the way to infinity. All right? Now, if you think about it, it makes sense. If you have a positive number, it doesn't matter if you have a negative exponent. It's still going to be a positive result. Remember that a negative exponent... Whoops, I'm losing focus here. Okay, there we go. So remember that a negative exponent doesn't change the value of the function to negative, but rather that it turns it into the reciprocal form. If you have 2 to the power of 2, it's 4. If you have 2 to the power of negative 2, it would be 1/4, still positive. All right? So no matter what kind of exponent we write, it will always be a positive number. All right, now, for point number 2, the graphs of all exponential functions of the form blah, blah, blah pass through the point 0, 1. All right, if you think about it, it makes perfect sense. Whenever our exponent is 0, our output, our y, will always be 1. That is what it's explaining in here. In other words, whenever we have an x as a variable, an exponent as a variable, we will always have our y-intercept to be 1, which is actually what is shown right here. All right, you see that it doesn't matter in what direction it's going, it's always going to pass through 1. Point number 3, if the base, b is the base, is greater than 1, then the graph will be going up from left to right. So this is when my base is a number greater than 1. However, on the flip side, we have point number 4. If the value of the base lies between 0 and 1, in other words, 0.1, 0.2, 0.5, all of those values are actually going to be going in the opposite way. All right? That has a graph that goes down from left to right and is a decreasing function. And again, if you think about it, it makes perfect sense. If you have 1 divided by 2, all of that squared, then as you increase the value of x, you're decreasing the value of y. It's getting closer and closer to our x-axis, which brings us to point number 6. I'm going to go to point number 5 soon, but I'm going to use this as a segue. The graph of f of x equals b of x approaches but does not touch the x-axis. Remember this? If it approaches but doesn't touch it, that means that we have a horizontal asymptote where at y is equal to 0. So every exponential function, or at least the base form, let's say, the parent function, if you will have a horizontal asymptote in the x-axis. And again, it makes sense. You can never make it 0. There's no exponent you can place here that makes the value of the function 0. If you have a really small exponent, it doesn't matter. If you have a humongous exponent, it doesn't matter. It will never be 0. All right? And finally, the function has a one-to-one correspondence and has an inverse that is a function. So I left this one for the last because we haven't really gotten too much into what exactly is that inverse function. All right, but hopefully we'll have enough time to discuss it later in the semester, what's left of it anyways. All right, so I'm gonna upload this and then give you the instructions for today's work. And later this week, I'll send you the rest of the work. Have a nice day. Good luck.